Assalamu alaikum. Today we will see lecture number 32 from the subject numerical methods, and today's topic is about Newton-Cotes integration formula, and we will just start unit number 3rd. Okay. In today's lecture we will see the numerical integration's basic or parent formula, that is Newton-Cotes formula. We are going to derive the Newton-Cotes formula, and by the help of that derivation we would learn other formulas which are used in numerical integration, like trapezoidal rule, Simpson's 3/8 rule, Simpson's 1/3 rule, etc., like Wedel's rule. So many rules we have, and we have to learn the process of using all these rules via the Newton-Cotes formula. So let us start the derivation of Newton-Cotes formula. You know that in numerical differential and integration, we have learnt that if we have some set of points, say let y is equal to f of x be a function and y0 is equal to f of x0, obvious बात है. y1 will be equal to f of x1, y2 will be equal to f of x2, and so on up to yn will be equal to f of x of n, where this x of n is basically equal to x0 plus n times h, and this is what we call as the interval from u is equal to 0 to u is equal to n. अगर आपको ये समझ में नहीं आया, let me explain it over here once again. You know that we have a data point like x1, x2, x3 and so on up to xn. We can, if we will start the data points from x0, so first one will be x0. We can write over here x0 plus h, that means interval size plus the first size, that would be equal to x1. x2 will be equal to x0 plus 2h. Similarly this will be x0 plus n times h. एक ही बात है, आप इस तरीके से लिखें, आप इस तरीके से लिखें. This is how we represent the intervals. Okay. By Newton's forward difference interpolation formula, we know that y of x is equal to f of x is equal to y0 plus delta y0 times u. Don't get confused. अगर मैंने यहाँ पे initial 0 से start किया, it doesn't matter. You can start from 1 as well. But it should be same, square y0 divided by 2 factorial u into u minus 1. This just represents कि आपने data set का representation कैसे किया होगा, plus delta cube divided by 3 factorial u into u minus 1, u minus 2 plus and so on, right? This much we know. Okay. And we also know that our u in this case will be equal to x minus x0 divided by h, and we can write this as x is equal to x0 plus u times h. And if we will differentiate this on this x, this will be x is equal to h times du, right? Okay. I am not explaining how the thing is because you already know all these things. If not, let me know, I will explain it once again. So we have to give the integrals from this y of x into this d of x, जो हमारे पास न्यूटन्स फॉरवर्ड डिफरेंस इंटरपोलेशन का फॉर्मूला है with respect to this differentiation. So this will be equal to x0. We can substitute xn के बदले x0 plus n times h, कोई इशू नहीं होगा. y of x के बदले हम सारी की सारी फॉर्मूला को सब्स्टिट्यूट कर सकते हैं, या हमें करना भी चाहिए, into u plus delta square y0 divided by 2 factorial u into u minus 1 plus delta cube y0 divided by 3 factorial u into u minus 1 u minus 2 and so on. हमारे सिलेबस के हिसाब से हमें जो रूल्स करने हैं वो यहीं तक करने हैं, थर्ड ऑर्डर तक, इसीलिए मैं फॉर्मूला को यहीं तक ले रही हूँ. अगर हमें आगे के रूल्स भी होते तो आई कुड हैव एडिड the other terms as well, but we don't have to do it, so let it be. All right, ठीक है. Into अपना d of x, instead of d of x we can substitute h times du. Everybody knows that this h is a constant and constants को हम integrate differentiate कुछ नहीं करते हैं, so we can remove this from here. So h will be from 0 to n. We can substitute it like this n as well. This is just the representation I am showing you in different ways. Plus delta square y0 divided by 2 factorial. This will be u square minus u, so I am writing u square minus u, isn't it? U into u is u square minus u. साथ साथ में सिंप्लीफाई भी करेंगे. u0 divided by 3 factorial is 6. इसको simplification के बाद what you are going to get is this will be u cube minus 3u square plus 2u, okay, and so on, ठीक है, into d times u. Now integrate the whole equation with respect to this u. So integrating with respect to u, what you are going to get is h of u y0 plus delta y0 u square divided by 2. I hope how you can do it, or you know how to do it. This is u cube minus 3 divided by 3 minus u square, putting limits and all these things. So I am simplifying this. Delta cube y0 divided by 6 u4 divided by 4 minus 3u cube divided by 3 plus 2u square divided by 2, and so on from 0 to n. Now simplify all this. So h will be equal to so if you will resolve the limits as well, this is what we are going to get is over here is like this: n times y0 plus, if you will replace u with n, कोई फ़र्क नहीं पड़ेगा, just to generalize this, divided by 2 n cube divided by 3. Sorry for this, I am not feeling well, but still I am trying to make you people understand this in a better way. Divided by 6 and 4 divided by 4. We are not doing nothing, but we are just replacing it with n square. I have already cancelled 3 and 3 out and 2 and 2 out, so that you can get this as well, okay? So it will be like this. Then this will be n y0 plus delta y0 n square divided by 2 plus delta square y0 divided by, if we will do the cancellation or this will be 12, LCM and all these things, this will be 2n cube minus 3n square, because this is 6 and this will be this, okay, plus delta cube y0 over 24. This will be n to the power 4 minus 4 times n cube plus 4n ka square, so on, and this there, this will be so on. Okay, so this formula is known as general Newton cotes formula. Now if we will put cases, like if we will put n is equal to 1, what we are going to get and which formula we are going to get out of that, we will see that tomorrow. This is just a general basic derivation of Newton-Cotes formula, which we derived from the Newton's forward difference interpolation method. Thank you.